Hi everyone, thank you very much for tuning on to this channel again. Like I promised on my previous video that I'll be starting with moments. So before I start with the topic for today, I would like to remind you about something that maybe I did not highlight on my first video. Should you really be interested on my videos, don't hesitate to give it a thumbs up or subscribe or either comments, of which I value them a lot because that's where you're going to raise your points and maybe there'll be improvements from your comments or clarity. All right, now let us start with our work for today. Right, looking on the slides that I believe that you can see, uh, I've I've given a picture of a spanner here. So I decided that, okay, before we do anything, we must first understand what is the moment. So a moment is the amount of travel that a plane has around a fixed point and is obtained by multiplying the force with the perpendicular distance between the point of rotation and the working line of force. That will be explained in few minutes. But I would like to say to you that many people can explain moments in different words, but the aim being the same. One can say a moment is a turning force around a fixed point, or one can say a moment is a turning effect of force, or in simple terms, one can say is essentially a force by distance. That's how it is. So we are talking about the force by distance. You can see the force is applied here and then at a certain distance. Here is your pivot, your turning point. So you're basically loosening up this nut with the spanner. So now the reason why I'm saying perpendicular is because this force here is making 90 degrees with the horizontal line. And we say moment is followed by perpendicular distance. The distance from the point of action to your turning point, right? And the closer you get to the pivot or the turning point, the less moment you'll obtain. Right at the end here, you're obtaining maximum moment, right? So now the formula to calculate moment is M equals force by D, which is basically this. I would like to emphasize that moment equals torque. Why do I put these two formulas here? Is because both of them are measured in Newton meter, which makes them the same, right? So here's the formula to calculate moment, force by perpendicular distance. Good people, do not forget that. And these four sketches here symbolizes what I've just said here. You can see from the first sketch, you're obtaining maximum moment. But the closer you get to the turning point or the fulcrum, the torque or moment reduces. You can see on the third one. Lastly, you're obtaining zero torque here or zero moment. Why obtaining zero? It's because there's no distance here. And the closer you get to the pivot, the less torque you'll have. I hope that is clear, good people. And this green arrow here symbolizes the direction of the spanner, symbolizes a moment. Force must be applied here in order for the spanner to turn, right? Now let us check this in application. Now, on our next slide here, I have taken the very same sketch that you have on my previous slide. So the only thing I'm going to do here is to add values here. I'm going to put the distance here as 0.5 meter and the force as 30 newtons, right? So now the question will be addressed this way. Calculate moment or torque that is required to turn the spanner. So you simply have to say moment equals D. Force by perpendicular distance. So you say 30 multiplied by 0.5 here. This will give you 50 Newton meter. This is your first sum, good people. I hope you can see how simple this calculation is. Right. From the very same sketch, I would like to shift this arrow here and change this dimension, just to see whether whatever that I've said, that when you move the force closer to the turning point, the torque becomes less. Now let us shift now. Let us say this arrow is right here now. Let us say this arrow is right here now, and the force is 30 still applied here, but now at a shorter distance, 2.5. So that is the distance now from the force to your turning point. So now let us see. We say moment equals FD. So in this case, your 30 is, your force is F multiplied by 0.25, and that gives you an answer of what? 7.5 Newton meter. So good people, this clearly shows that the closer you get to the turning point, the less moment you obtain. I hope that answers the question, good people. Thank you very much for watching. Let us meet on my next video. Thank you very much for being with me today.